Thank you for joining the November 12th, 2019 VOLTHA call. Just a reminder to everyone that these meetings are public and recorded, and we post them to our YouTube channel after the meeting. So please be mindful of that during the discussions and any presentations that we may have today. So on today's agenda, we have a few topics, just a quick review of the new Girish. So before I started the call, it looks like we've got Vol 2195 through 2225, and they all appeared brigade related. We'll do another check during the meeting, and then all discuss Girish. There was one I received an email request for shortly before the call, so I'm not sure if we'll have the right attendees on for discussion today, but we'll see if we can pull the group together. And then the final item for today would be a review of the workflow document that Sarah will go through for us. Any questions from the bridge? Okay, then let me go over to the new Girish just to refresh, see if anything else has come in. And it looks like we're still at 2225. So again, I took a look at these, and since we're putting unit tests under maintenance and stabilization, I believe all of those and then the defects are all covered under brigades. And so I did not see any new items for discussion with this group. If there's anything particular folks wanted to bring up, please let me know. I'll give just a moment for responses. Okay, then next, let me see who we've got on the bridge for this 2180. So 2180 context timeout addition to etcd client APIs. This one, I think we need Ken and Scott. I see Scott on here. I see Ken. I think we also need Thomas, unless there's someone else from Radisys who can talk about this issue. Okay, it was just brought to my attention.
Yeah, this is Scott. I don't know that. Well, I reviewed the patch, and the patch looked reasonable to me, that it did what Thomas said it would do, but I'm not familiar with the issue that he was trying to fix.
Okay. So I think, go ahead.
Yeah, so pretty much it's, I think this originated from one of the comments that I put on his patches. Basically what it is, it's what Thomas did is correct in the sense of in order to, when you can talk to etcd, we should always have a timeout. So he put a timeout there, which is right. The only thing is usually, and we should have done that before, we didn't do that, in an API call, especially in Go, it's better to have a context that passed in, and the context would be like, that's where the timeout can be specified. And so that's a better implementation by having, and since this client, the etcd client that is making changes, is in the library, so it's even more important to have a context passing as a parameter. So really, I think this implementation needs to be done. The code that Thomas did will still need to be, is still of value, because if somebody passes a context as a nil, we'll still need to have a default timer. So it's really, we need his code, but also we need to have context passed in as parameters in the library.
If we're expecting a context passed in as a parameter and someone passes a nil, isn't the correct response to throw an error, bad parameter, whatever, not do a default context?
Well, we could do that, or we could also have something default in the code where we says, well, if you don't have a context, we'll have a default by.
Do any of the other calls that take context do that?
In VOLTHA, yes, there are some places that we do that.
Okay, in
So, but
non-VOLTHA typical Go.
that I don't have no idea.
If there's a required parameter, and to me, when you're making these calls, a context is a required parameter. Throw one in there. You can always, there's the default context, which is part of Go, right? The to do or whatever it is, or background. I do not think we should be creating context, black magic behind the scenes.
Yes, but on the other hand, like somebody can pass in a context, and this it's kind of a to-do context. It doesn't have any timeout, nothing in it, right? So it's like the context will be valid, but if we use that against etcd, it will never time out.
That's fine, and that's an error in the code, their code that passed it in. I don't know. If I look at normal Go, you pass a context. If you screwed up creating the wrong context, that's not the library's fault. We can't protect from some of this stuff. And what happens if they pass to do? Are you always going to add a timeout to it? Check if there's a.
Yeah, so like how much check we want to do, right? Like because if it's just if it was just a context, right? Like we always know that it will have a timeout. It's okay, but if we don't have a timeout, all right. So that's the thing. And when we make a call to etcd, we should be able to bail out if it's taking forever, right?
Right, and maybe they're implementing a timeout differently. Maybe they've got a cancel context, and they've got a timer somewhere else that's managing and canceling it. I think it's going to be problematic and lead to other issues if we try to outthink the caller. If a context is a parameter, pass in a context.
But I don't see how they will be able to cancel it, because once we talk to etcd needs to have a timer in it, like when you make that invocation, right?
Throw the correct they should use the correct context. All I'm arguing. So what happens if someone passes to do in as a parameter? Are we always going to add a timeout to that context?
We could, but but should we? Right?
Yeah, right. So unless you're going to add a timeout to every context to guarantee every context is a timeout, you can't do this. And you can't guarantee that every context is a timeout. And I don't think we should do that. Therefore, we shouldn't do anything. You should just take what they give you and require them to give you something.
Like we didn't even have the timeouts in very recent history. Now we're going sort of being the pendulum the other way and absolutely requiring every single time to have a timeout and enforcing it.
No, everybody'd have a context.
Right, but so yeah, I much more agree with just you must pass in a context. If somebody passes background, we're just going to assume they're testing. We're going to assume they're going to fix it later. Just go with what they do. It's extra code that's not really necessary if people are using the library properly. So.
I mean, if we need a convenience routine to create a context with timeout, that's easy enough to do. That's 2 lines, but it really isn't hard to create a context with timeout. I mean, if we want one so that we have a standard timeout that people, say, hey, you use this context with a standard timeout and you're good. Okay, fine. Give them that constant to do that. But I wouldn't do it behind the scenes if you happen to pass null. This way, the person writing the code is very aware of what's going on, and I personally think that's just kind of a leads to better, more manageable code.
But I don't know how we can enforce that. That's a problem.
We can't.
Right?
We can't.
Yeah.
I'm saying we shouldn't. We should say, look, you need a context. Right? Pass in a context. By the way, okay, let me back up. If I use a context, just a background or to do, what happens? etcd either returns, or if etcd has a problem, it just hangs forever?
Yeah, it will hang.
Okay. Only if there's an error.
If etcd is gone, for example, right?
Yep.
Then it will just hang.
Okay, if etcd is gone, we've got other problems, and this process hanging, not going to be my biggest issue. I'll be honest, right? If etcd is gone, the etcd cluster is gone, everything is completely messed up. I'm losing
Yes,
data. So
yes,
the fact that
I
this
understand
hangs,
that, but
not
you
my
want to
biggest
give,
issue.
yeah, but you need to have an error that's get populated back. So if anybody is behind, if an operator is doing something, an action, you want them to get an error back, right? Today there's no error back. If etcds hang, then we will just wait there.
Yep.
So do we want that behavior?
I think I agree with Ken. You know, David, we want the core to start reporting, you know, readiness errors and timeout the operations back to the client and such, rather than an operation just blocking forever and possibly wedging up part of the core.
We're trying to program smarts in where I don't personally believe they belong, right? If I look at the libraries that Go typically uses, if something requires a context, it's up to you to put a context. If something requires a context, it's up to you to put a context with a timeout. It's up to the caller to put a context with a timeout.
Yeah, I agree with. So I'm going to agree with both Ken and David, but I'm going to say that
You've got the cube, Scott.
I'm going to say that.
Just kidding.
David, you're right on like syntax. The function should take a context. Ken, you're right that someone should supply a context that has a timeout in it. So it's a matter of if someone gives it a context that doesn't have a timeout, that's a mistake. But I don't think it's our responsibility in the code to police all mistakes.
Can we create call it a default KV context, which has a timeout with a default timer of whatever we want to set it configurable. And this way, look, we can say always pass a context, document it. Context should have a timeout. If you don't want to create a context or don't know how, here's a constant, use it. You know, have our own to-do, if you will.
Yeah, I kind of agree with that. If we make that in the library, yeah.
Because that way, if you pass null, they get an error, and then they know, oh, they got to use a context, and then they can just say have a VOLTHA timeout context or whatever we want to call it, and they can just throw that the constant in there.
You have to.
Yeah, that will work. Yeah.
Okay, I'm gonna shut up now then.
No, you're just starting. Come on.
I haven't had my coffee yet.
Okay, so as I was trying to listen and type, I don't think I captured this quite correctly here. What do we have then as our agreement that you'd like documented in the notes?
Basically, a parameter will be changed from a timeout to a context, and we'll trust people to supply a timeout with that context, and we'll add a default context, if you will, with the default timeout, so that people don't have to think about it if they're not ready to.
And are we going to plumb this through to like a config option someplace so it's changeable, or do we feel a static constant for the default is correct?
So my vote would be a static context for the defaults, simply because you shouldn't really be using it anyways. Like it's already a to-do. So that's my vote.
Yeah, I wouldn't worry about plumbing it, to be honest. I'd even go so far and I don't know if you can check if the context passed in as a timeout. I could, see an error thrown too if that gets an error. I don't know if you can do that or not.
No, you can't do that.
Yeah, but I wouldn't worry about it.
Okay, Anything else we need to discuss on this topic today? Then since Thomas wasn't here, what I'll do is I'll point him to the recording, and then we can follow up either Slack, VOLTHA Discuss, or on the next VOLTHA call if needed. Okay, anything else? And let me just go back and make sure nothing else is flagged. Okay, I don't see any others. So our next topic today, I believe, Saurav, did I see you on the bridge?
Yes, I'm here.
Okay, I think our next topic is Saurav was going to go over the workflow document. Do you want me to give you presentation rights?
Please. Okay. So over the last couple of weeks, Gamze, Girish, Amit Ghosh, and I have been working towards nailing down some of these, the differences between each of the operator workflows and how that affects, VLAN translations, TCONs, requirements for multiple unis on the same ONU, different ONUs, what OLT should do, a variety of things. And it was not trivial to understand all three different workflows. Even if you wrote it down. So what I did was I captured those differences, or actually captured each workflow on a set of slides, and I felt that it's really no good if only the four of us understand these differences. So I felt the need for a larger community to be aware of them, have a place to reference it, should they have more doubts, and so on. So I'll show you where the location of this slide set is after I discuss these slide sets. So to start things off, AT&T's workflow is the one that we know the best, right? In that case, you have either untagged or VLAN 0 priority tagged packets coming from the residential gateway. And so an ONU typically has a single uni, but multiple unis are also possible. I'm not completely sure if AT&T really needs multiple unis, but if it is there, I mean, this is how it would work. And so the priority tagged packets then get mapped into, depending on the priority and the tech profile specified. The tech profile is a 1 TCON 4 GEM-TREC profile. So those priority tag packets, according to the p-bits, get mapped into those GEM ports and then get scheduled into a TCON. The VLAN tag gets translated into a VLAN tag that identifies that particular subscriber, right? So if you had multiple unis on the same ONU, the VLAN tag will get translated into something else that represents that particular subscriber as opposed to this one, okay? And then upstream, these packets end up at the OLT. And so they all have different C tags, right? That's the inner tag. So stag.c tag. So the C tag is identifying the particular subscriber, and the S tag typically identifies the particular on port. So a different PON port could have a different S tag. the S tag and C tag will uniquely identify this particular subscriber and its location on a particular PON port. Okay, so this is the one that we understand. This is the one that we've been using for a while now. But now if you look at the Deutsche Telekom workflow for fiber to the home, right? It's actually looks very similar to the AT&T one. The one difference, but there are differences, right? So the first difference is that instead of VLAN 0, right? We had VLAN 0 in the AT&T case, but here the VLAN that is coming from the RG could be literally anything, right? It's, you know, customers go to a store, buy a box, and that box may have, you know, whatever VLAN, we don't know, right? So that's why it says VLAN any, okay? And then it hits the ONU, and again, there's that pbit mapping, but this time to 1 TCON and 8 gem ports, okay? So each pbit gets its own gem port. Think of these as queues, right? And then your TCON schedules between these queues. But what happens to the VLAN tag is that it's preserved. You know, whatever that VLAN tag was, it just stays that way, right? So, and that's true across all the ONUs. It just stays that way. So how do we identify the subscriber? Well, the identification happens here, right, at the OLT. So it's the S tag that represents the, or rather it's the outer tag, right, that represents the particular subscriber. So again, the inner tag, whatever that was in the RG, it just stays preserved all the way through. And this particular subscriber gets VLAN 7, this particular subscriber gets VLAN 8, and so on. So, so that's pretty much it for the DT's fiber to the home workflow. And so you can see that, you know, there are differences from the AT&T case. There's differences in the 1 TCON 4 gem versus 1 TCON 8 gem. There's differences between what VLAN you're actually getting from the RG. And there's differences in the VLAN tagging and what they represent. Here, the outer tag represented the PON port, and the inner tag represented the subscriber. But in the DT case, it's the outer tag that represents the subscriber, and the inner tag is just transparently carried through all the way from the RG to upstream. So before I go any further, is there any questions? Does anyone have any questions?
Yes.
Yes, go ahead.
Will you not run out of S tags very quickly in this scenario? Because like an S tag is only, I don't remember how many bits it is, but my recollection.
Well, all VLAN tags are 12 bits, so you have 4,000 subscribers, right?
Okay, and the assumption is you just never have more than that.
Well, so it's unique on an OLT.
Right.
So you won't have more than 4,000 subscribers on an OLT. So across all the PON ports on the OLT, you'll get unique S tags.
Okay.
I think what happens is in the DT case, if I remember from a past presentation, an MPLS label is used north of the OLT to transport it across the larger network. So you don't have to worry about SVLAN collisions in that case because the SVLAN is not really addressed in the transit network.
Yeah, I think we're also looking at a P4 top of rack as well, so they can be.
So yeah, I think that addresses the VLANs. It basically just means you can't have more than 4,000 customers on a single OLT, but north of that OLT, it's dealt with MPLS.
Okay, makes sense.
Any other questions? Okay, so now I'm going to move on to the more complicated case of the fiber to the, it's called FTTB. I'm not sure what the B is. I think if I were to the basement or business or something like that, right?
I think it's business.
What is it?
I think it's business.
Business, right? But okay, so the point is that you have now your ONUs are actually embedded inside another box called the DPU, right? Distribution point unit. And from that distribution point unit, there are GDOS fast lines, basically twisted pair, going to up to another 16 subscribers beyond the DPU, right? So this was my best attempt at drawing twisted pairs, sorry. So here's what's happening over here. Again, you have no control over the VLAN tag, the inner VLAN tag that is coming from the CPE. So it could literally be anything. But once it hits the DPU, it's the DPU that differentiates between each of these subscribers, G.fast subscribers, with an outer tag that represents, that particular subscriber. So for example, 33 is the outer tag for this red subscriber, and 48 is the outer tag for this purple subscriber. But notice that in a different DPU, you could have exactly the same 33 representing this particular subscriber, 48 for this one, right? So the DPUs are sort of independent, and they do their VLAN tagging based on whatever, and there could be they could be exactly the same somewhere else, right? So again, it's at the OLT that the differences between these subscribers are maintained. So I'll show you how in a second. But what happens once it enters the uni, right? So depending on what, so each subscriber gets its own 1 TCONT 8 gem. Okay, so if there were 16 such subscribers, there'll be 16 such TCONTs, each with 8 gems, right? Again, the p-bit mapping gets mapped into each of these gem ports, and then they get scheduled for the TCONT for that particular subscriber. So I've only drawn 2 of them, but there'll be 16 of these. And then there will be an additional TCONT, the 17th TCONT, which is meant for management traffic. Okay, so management traffic will come on 2 different VLANs. One of them is 12, the other one is 4090. These are just examples, could change. But this management traffic is for the DPU to be managed in band by a separate sort of DPU controller sitting upstream somewhere beyond the OLT. Okay. So this management traffic coming from the DPU will similarly enter the logical uniport inside the DPU and then get mapped into a 1 TCONT 1 gem structure, and the VLAN tags are going to be preserved. Similarly, all of these subscriber VLAN tag, whatever came from the CPE, and then the DPU added the 33 or the 48 or whatever, that also gets preserved through the ONU. Again, this also gets preserved through the ONU. It's the same VLAN tags, right? But then, excuse me, upstream, that VLAN tag is translated. So the 33 NE that came from this particular DPU gets translated into, say, 540. And the 33 NE that came from this DPU got translated to 840. Okay. And so that's how, so in the FTTH case, it's the outer tag that was, identifying a particular subscriber. But in the FTTB case, it's the outer tag that identifies a particular subscriber again.
Is that mapping a standard type mapping, a formulas type mapping, or is it what you got here just examples?
These are just examples.
Okay,
Okay, so all of this is specified in the subscriber, the status configuration. And of course, this 12 and 4090 gets preserved and passed upstream. Of course, on the way back then, you don't know where this 12 and 4090 are supposed to go unless you also learn the MAC address and then differentiate that traffic based on the MAC address. So there is a whole MAC learning step where you learn the MAC address of this particular DPU. And then on the reverse direction, the destination MAC address will be either for this DPU or for this DPU. And on the basis of that, you can send that traffic down to this guy or this guy, right?
So in this case, is the ONU component of the DPU doing the translation from 33.NE to 540.NE?
No, it's actually happening in the OLT.
So
depending on which gem port, yeah, sorry, go ahead.
Okay, so I mean, you'd have to use a unique gem port identifier then to do that translation, right?
Yes. I'm not showing the gem ports over here.
Yeah, I mean, that's not a standard match action rule, right? I mean, how is that then under the covers?
But in port is, right? Incoming port is a standard match.
Yes.
So the incoming port is going to be different, right? So for example, the uni port over here is different from the uni port over here.
That's right, in the upstream. Yes. So in the downstream, okay, I guess in the downstream that's unique. Okay.
You already have 540 is different from 840.
Yeah.
Right?
Okay. Yeah.
Okay. Is this clear? Any questions on the FTTB workflow? Now, the one thing is that the FTTB details could change, right? It's not final yet. And I've asked Bjorn I'm asking Amit also to finalize this so we can start implementing this. So hopefully that will happen soon. But this is the detail of the FTTB workflow as of now. Okay. And then the final one that we'll move on to is the Turk Telecom workflow. And so far, any of the three workflows that I've shown you, the differentiation between the types of traffic is happening from the p-bit mapping to a gem port, right? That happens, say, in the ONU over here, right? In each case, is the tech profile specifying the p-bit mapping? And then based on that p-bit mapping, you are differentiating different types of traffic into different gem port and then scheduling it differently. The Turk Telecom workflow is slightly different, where, again, in this particular example, you have three different subscribers. And then instead of using, there's actually separate ports on the residential gateway for different kinds of traffic, right? So high-speed internet has one port, voice over IP has another one. Video on demand has a third one. It's the same port that is used for IPTV. Okay. So in the Turk Telecom workflow, what's going to happen is that, again, there are different ports that are used, but exactly the same VLAN will be put in by each RG. So 35 will represent high-speed internet access, 65 for voice over IP, 55 for video demand. That's the same across all three RGs. Okay. And what happens is that, so each is a different service, and each service gets its own tcont. Okay. Notice that in the previous cases, each subscriber was getting its own tcont, right? So if there were 16 g.fast subscribers, you would have gotten 16 tconts. In this case, each service is getting its own tcont, and that tcont is shared by all the subscribers that are on the same ONU. So these are two different subscribers. They have both their high-speed internet access traffic with VLAN 35. That VLAN 35, for both these subscribers, they end up sharing the same tcont because the tcont is mapped to a service. And that's true for all three different kinds of traffic. So their VLANs may or may not get translated. Their p-bits do change upstream to downstream, but this is one case where you're not using the p-bits from the tech profile. You're actually specifying the p-bits in the in SADIS, and therefore it's getting translated from one VLAN to another, from one p-bit to another by ONOS in the match rules that are coming down. So if the match rules are actually specifying p-bits, then you use that in VOLTHA. If they're not specifying any p-bits, then you use the p-bit mapping specified in the tech profile. Okay, so what you end up with, let's trace one kind of traffic. HSIA is this red one. So you see it got translated to, so in every case, it was 35 coming in, VLAN 35, it got translated to 33, 34, and 133. Identifying three different subscribers. And when you go upstream, it's, so 33, 34, and 133 are preserved. That's what identifies the particular subscriber. And the service VLAN, the outer tag is 7. That identifies the service, which is high-speed internet access. Okay, so in the Turk Telecom case, the outer tag does not specify the PON port as in the AT&T case, does not specify the subscriber as in the DT case, but it actually specifies the service, which is high-speed internet access. Okay. Right. So on the downstream, again, high-speed internet access is easy because you have 33, 34, and 133. That's how you are going to know which subscriber you're going to send that traffic downstream to. But if you look at voice over IP and voice video on demand, they might end up with the same VLAN, right? So it's 65 coming in becomes 63. It was 55 coming in, stays 55, and then keeps going upstream. And the service VLAN for voice over IP is, let's say, 1546. So all these three subscribers traffic end up with the same VLAN tags, 1546 for identifying voice over IP, and 63 identifying whatever came from the RG. So in the downstream direction, again, you'll have to use the MAC address to match identifying the particular subscriber. So that's true for voice over IP as well as video on demand, right? The same VLAN tag combination goes upstream, but on the downstream path, to know where to send the appropriate traffic, you'll have to learn and match on the MAC address. One final service is the IPTV service. Of course, that's only unidirectional. It only goes downstream. And that's again on this VLAN 550. And that's the same VLAN that's preserved through the system. So you can see that there are significant differences between each workflow. Significant differences between, what tcont gemport combinations you want. In one case, it's shared between subscribers. In another case, it's every subscriber gets its own tcont. In some cases, the VLAN tagging means different things, right? The outer tag in Turk Telecom's case identifies a service, whereas in other cases, it can identify a subscriber or even a PON port. And so there are different VLAN tag manipulations that have to be done in each workflow. The p-bit mappings are different. And so it's really important that we, more people internalize these differences. If you want to know where it can be found, this slide set, you just need to look in the same VOLTHA folder under design documents. All of this has come out of this multi-TCON design. So what you want to look at is this, and if you want a textual explanation, that can be found in this status configuration. Status configuration, which is here, right? So even in this document, it points to the slides that I was just showing, and then it goes through some of these, differences between each workflow and how we have changed status to work for all three operators, right? And then there are examples of how services or how the status configuration is going to look like for FTTH, FTTB, and so on. And then what changes happen, and some examples of what the flows are going to look like for the three different operators. Okay, so that's all I had. Any questions?
Just a note on the difference between like Turk Telecom, where you're basically sharing TCONs and DTC. So that's also controlled from the tech profile as the instance control. So basically ONU instance determines whether it's shared or it's not shared.
That's right. So Girish is working on the implementation of the instance control, and that's right. So it's the tech profile that specifies where these TCONs need to be shared across subscribers, across unis, or they are unique for a particular subscriber.
So while some of this is going to be handled by the tech profile, some of this is going to also be handled in the OLT app in terms of some of the new flows that are going to be pushed down.
Correct.
Back learning, that type of stuff. So we're going to see changes in that as well.
Oh yes.
Okay.
So that's why and it's not all going to come in together. It's not all going to work together. So that's why we released the ONOS apps, so that the community that is not working on this particular thing can still continue to work using the released versions of the apps, while the rest of us, while the people who are working on this have moved on. So the new status configuration is already in there, it's merged, but most people aren't aware of it because they're using the released versions of the apps in kind VOLTHA. So it's not disruptive to them. And slowly we'll have more and more changes come in. And eventually when things work together, then we will do a new release of the apps.
Is there a provisioning flag that indicates whether a service is N-to-1 or 1-to-1? So,
I don't think we have considered that. Nobody's brought up an N-to-1 in these scenarios. Are you aware of anything, Sean?
Well, basically the Turk Telecom one, where basically you have just basically either a single S tag or like the VoIP service is N-to-1, right? So basically it's using MAC learning to forward.
Ah, I see. Okay. There is a Mac learning flag. So in the status configuration, let's see if I can show an example. So this first one is for HSIA. So that's just normal. This is the incoming tag. That's what it gets translated to. This is what the OLT puts on it as the outer tag. And then these are the priority bits that get translated from whatever comes in to whatever it needs to go out with. It points to a specific technology profile, upstream and downstream bandwidth profile. That's the service name. But if you compare that to the VoIP service, there's actually some extra fields over here that say that, that go ahead and enable Mac learning. So then we'll actually use Mac learning. Or you can actually go ahead and specify the MAC address to use for a particular subscriber. This is typically just for testing, I feel. Most of the times you'll just have enable Mac learning true. And that would mean the N:1 that you are saying.
Yeah, okay. I guess you could have just also enabled Mac learning on the HSIA as well, but it's really the in and out of tag that forwards it, or depending on if it's AT&T or DT, it could be just the outer tag. But, okay, makes sense.
So currently you believe you can implement, or we can implement all these different workflows based on essentially settings in the status record.
Yes, that and the tech profile. That and the tech profile. They go hand in hand, right?
Yeah. But we'll, for instance, the OLT app will now have to look up information from status to determine its behavior.
Correct.
Which flows it pushed down. All right, and you think, okay.
I think just to answer Sean's question that why not enable Mac learning for HSIA. So I think for Turk Telecom, they don't use DHCP for HSIA service. And for others, they do. And that's how they trap the DHCP packet all the way to the ONOS to do the Mac learning.
Yeah.
But for HSIA, they can't.
Yeah, that's right. Some operators like to enable Mac learning even from one-for-one services, just from a debug perspective, so they can see, what's going on in terms of MAC addresses. But yeah, that's okay. I think that works pretty well.
Yeah, so the HSIA service is actually the one that's on PPPoE, but at least on the OLT, ONU level, the PON level, PPPoE just goes through transparently. We don't actually see it. But that's the only one that uses PPPoE. The others don't. The others are actually using GHCP. Yeah, go ahead. Hello.
And it's also one-to-one service, HSI service, so no need to make address. Subscribers already have their unique tags, so no need to make address to route the traffic.
Yeah. It's just. I mean, some operators do it. I mean, operators do things different ways, but this works fine.
Clearly, operators do things different ways.
Yeah, I mean, every operator.
This presentation. Yeah, I was actually quite surprised, actually.
Yeah, I mean, I think I've seen the models from tens of different operators, and they're all different, essentially.
All right. Any other questions, comments, frustrations?
For Turk Telecom workflow, there's something different to locate the OLT. So from the fabric to the OLT side, we need to know which OLT we should forward the packets, right? That is something you talk with with Cemil and Mahir at the lockdown meeting.
Yeah, except that, yeah, I haven't focused on that part, actually.
Is that a multicast question?
Yeah, correct. Multicast also is a solution for this problem.
Okay, I didn't follow you. Are you saying for, so if you have an aggregation switch over here, we'll have to be able to differentiate between, the multicast going to this particular OLT versus any other OLT? Right?
Yeah, correct. I mean, in one service, sorry, there's a background noise somewhere. So in end-to-one services, because we need to route the traffic through the fabric to the correct OLT, and then from the OLT to correct ONU. From OLT to ONU, we are using the Mac learning feature to learn the correct route. The same problem is also there on the aggregation layer, because you don't have specific text to identify the correct OLTs also.
Right.
So in downstream, there's also a problem in Fabric to address the correct OLT, and the solution for this probably is, again, Mac learning in Fabric.
Okay. Yeah. That's right. Okay. Any other questions?
Yeah. Like I guess ONOS knows that, right? Because
I mean, if you learn it one place, if you learn it in one place, and assuming you are using a trellis-based aggregation switch, you learn in one place, you can use it in both places. Now, the work that we are doing now in this, the aggregation switch is out of scope in the sense that, it's not part of the common core that we have agreed on between the three operators. So,
yes.
So, it's something that we'll have to deal with separately. Any other quick questions? We're almost at the top of the hour. Okay, so you know where it's located. And so if you have any further questions, please feel free to either comment on the text or on the diagrams. Okay, but I do encourage more people to internalize these differences, and you will see these coming up in a near future version of VOLTHA and ONOS. Okay. Thanks, Julie. That's all I have.
Okay, thank you. Then I think we are pretty much out of time, so let me just see if anyone has any last comments before we drop the bridge today. All right, we'll go ahead and wrap up the meeting. I'll stop the recording, and thanks everyone for your participation.